network switch is a crucial component in computer networking that plays a key role in facilitating the communication between devices within a local area network, LAN. Unlike a hub, which simply broadcasts data to all connected devices, a switch intelligently manages data traffic by directing it only to the specific device intended to receive it. A network switch typically has multiple ports to connect various devices, such as computers, printers, servers, and other networking equipment. These ports can range from a few to several dozen, depending on the size and capacity of the switch. Network switches use different switching techniques, with the most common being Ethernet switching. Ethernet switches operate at Layer 2, data link layer, of the OSI model and use MAC addresses to forward data frames to the correct destination. The switch maintains a MAC address table that associates MAC addresses with the corresponding port on the switch. This table helps the switch make intelligent decisions on where to forward data packets based on the destination MAC address. Unlike hubs, which create a single broadcast and collision domain for all connected devices, switches create separate domains for each port. This isolation enhances network performance by reducing collisions and optimizing bandwidth. Switches can be categorized as managed or unmanaged. Unmanaged switches operate automatically and are plug-and-play devices, whereas managed switches offer more control and configuration options, allowing network administrators to monitor and optimize network performance. Some switches come with Power over Ethernet capability, enabling them to provide power to connected devices like IP cameras, VoIP phones, and access points through the same Ethernet cable used for data transmission. Managed switches often support VLANs, allowing network administrators to segment the network into virtual LANs. This enhances security, isolates broadcast domains, and provides more efficient use of network resources. Advanced switches support link aggregation, where multiple physical connections between switches or devices are combined to create a single high-bandwidth link. This improves redundancy and enhances overall network performance. Many switches support quality of service features, allowing administrators to prioritize certain types of traffic over others. This ensures that critical applications, like voice and video, receive the necessary bandwidth and low latency for optimal performance. Managed switches often come equipped with security features such as MAC address filtering, port security, and access control lists, ACLs. These features enhance network security by controlling which devices can connect to the network and what resources they can access. Managed switches provide the ability to monitor network traffic, track performance metrics, and diagnose potential issues. Remote management interfaces, such as SNMP, Simple Network Management Protocol, or web-based interfaces, enable administrators to configure and troubleshoot the switch from a central location. Network switches are designed to scale with the growing needs of a network. Modular switches allow for the addition of expansion modules or the stacking of multiple switches to accommodate an increasing number of devices and higher data loads. Some modern switches incorporate energy-efficient technologies, such as IEEE 802.3az Energy Efficient Ethernet, EEE. These features help reduce power consumption during periods of low network activity, contributing to a more environmentally friendly network infrastructure. To ensure continuous network operation, many switches support redundancy features like Rapid Spanning Tree Protocol, RSTP, and link aggregation. These mechanisms help create resilient network architectures by providing alternative paths and preventing network loops. Network switches are compatible with various networking protocols, ensuring seamless integration into diverse network environments. They are a fundamental building block for both small office/home office (SOHO) setups and large enterprise networks. Like any electronic device, switches benefit from periodic firmware updates. These updates may introduce new features, improve security, or address performance issues. Regularly checking for and applying firmware updates is a good practice for maintaining a healthy network infrastructure. Network switches are designed to seamlessly integrate with various network devices and platforms. This includes compatibility with different operating systems, network protocols, and hardware configurations, ensuring flexibility in building heterogeneous network environments. Managed switches often support dynamic VLAN assignment based on factors such as user identity, device type, or location. This dynamic segmentation enhances network security and simplifies the management of a diverse range of devices connecting to the network. In the era of cloud computing, some advanced switches offer cloud integration features. This allows network administrators to manage and monitor switches remotely through cloud-based platforms, providing flexibility and accessibility, especially in distributed or remote network setups. Many switches include built-in traffic monitoring and analysis tools. These tools provide insights into network utilization, identify bandwidth-intensive applications, and assist in optimizing network performance based on real-time data. Managed switches often support both in-band and out-of-band management. In-band management occurs through the same network infrastructure that carries regular data traffic, while out-of-band management involves a dedicated management network, providing an alternative for configuring switches even if the main network is down. For users who require more control than an unmanaged switch but don't need the full capabilities of a managed switch, smart switches offer a middle ground. Smart switches provide a level of configurability between unmanaged and managed switches, making them suitable for small to medium-sized businesses. An evolution of PoE Plus delivers higher power levels to connected devices. This is particularly useful for supporting devices with higher power requirements, such as advanced IP cameras, video conferencing equipment, and Wi-Fi access points. Managed switches often feature remote troubleshooting capabilities. Network administrators can diagnose and resolve issues from a central location, reducing the need for physical presence at the switch location. This is especially valuable in large or geographically dispersed networks. Manufacturers and networking communities often provide educational resources and training materials for using and configuring network switches effectively. This helps network administrators and IT professionals stay updated on the latest technologies and best practices in switch management. Some advanced switches support zero-touch provisioning, streamlining the deployment process. This feature allows switches to be automatically configured and added to the network with minimal manual intervention, reducing the time and effort required for initial setup. Port mirroring, also known as SPAN, Switched Port Analyzer, is a feature that allows the switch to duplicate and send network traffic from one port to another. This is particularly useful for network monitoring and analysis, enabling administrators to inspect the traffic passing through a specific port. Managed switches often support advanced security protocols such as IEEE 802.1x, which provides port-based network access control, and SNMPv3, which enhances the security of management communications. These features contribute to building a secure network infrastructure.